Hi everyone. So in the series of GATE 2023 question PYQ, okay, like previous questions, we have already discussed network theory questions and signal and system questions. So I believe you guys might have got some new insight how to solve questions. Now in this session, I'm just going to take communication question, the subject which people feel difficult, but those who have attended my class, they do not feel difficult, right? So let us see how we can approach to communication system problem, right? So all the questions we are going to solve, around 6 questions are there, and we have to also see which question was quite different, right? Okay. So let us start the question here. So the very first question was there in communication system from for electronics and communication in 2023, right? So this question was from random process and random variable random process. Okay. So without spending much time, we will solve the question. So for real signal, okay, the moment they have given real signal, this is very, very important. For real signal, which of the following is or valid power expected density? So they are just asking what is valid power expected density. If you know the property of power expected density, what is power expected density? The power expected density is nothing but the Fourier transform of autocorrelation function. If you know the ACF, if you take the Fourier transform of this, that will give us power expected density. This is very important, right? So whatever property this ACF has got, the same property that you can apply for PSD. So the first property that you have to check here is your power expected density must be what? Power expected density must be positive, right? And the second property that you have to check it should be even. These are the two property that you can verify. The first option will be correct because you can see here it is positive, okay, and it is also even. This is also correct, okay, it is also even, but this will be wrong because this is odd power expected density, okay. So power expected density cannot be the odd one, right? So this is odd function, right? So this cannot be the power expected density, and this can also not be the power expected density. So here this is a MSQ question. So A and B is the correct answer. So if you are confident enough, okay, if you are prepared well, okay, under the guidance of me, okay, so there should not be any problem at all, right? So this is what you have to solve it. The question number 130 is done, and this was for, I believe, 1 mark question, so it doesn't take much time. Now the question number 36 we have to solve, right? Question number 36. So as long as you can see here the question, this question is from random variable, and the question is from transformation, right? So a random variable x distributed normally, as you can see here, this is the normal distribution they have given, okay. So normal distribution is there, undergoes transformation by equal to h of x, right? By equal to h of x given in the figure. The form of the probability density function by is what, right? So as you can see here, if you take a look at by, right, and x is nothing but a random variable which is normally distributed, okay. So if you try to look at the density function of normal distribution, right? So I mean for random variable x, so this is the density function, okay. The mean is 0, and this is the Gaussian kind of situation, right? Okay. Now what you have to do here is there are options like first option, second option, third option, okay. So you have to notice here is that this by takes what kind of values, okay. So by is taking, you see here, by is taking one value, that is 1, and then it is continuous as well. By is taking 0, okay, and by is taking -1, right? So by is taking 3 values, okay. So by, you can say, is kind of a discrete random variable, as well as sometimes you see after 1 it is continuous as well, right? You see, okay. So by is kind of a discrete random variable, you can say, right? Kind of mixed random variable also, you can say, right? Mixed random variable, okay. So you might have seen continuous random variable, you might have seen mixed random variable, you might have seen discrete random variable, right? So the by is nothing but here the mixed random variable, you can see, okay. So by is taking what, you see, by is taking 1, okay, by is taking 0, by is taking -1. So in the options, if you come down in the options, right, by takes, by is a random variable, by takes -1, 0 and 1, right? These are the discrete values that it takes, and some continuous value also, okay. So that's why they have given these g by, understood, in all the options. So first options, you see, this cannot be correct because by is only taking, you can see 1 or -1, okay. So this cannot be correct. This can also be not correct. By is not taking 2, by is not taking -2, by is not taking, okay, these options are wrong. Only B option can be correct, right? So this question was direct, okay, and it's a very easy question they have asked. right, from random variable and random process. Okay, so you have been given a continuous random variable x, okay, that is nothing but a normally distributed random variable, and you're transforming by equal to h of x. Some transformation is given here. Okay, so you have to see always what value of by. By is nothing but a random variable, and what kind of random variable it is? It is nothing but a mixed random variable, you can say. So it is going to take three values here, discrete values, and how to represent discrete value with the help of impulse. Okay, fine. Question number 36 is done. Question number 45. Okay, so before we solve this question, I will come back to solve this question because this question needs a little bit of calculation. So I'm just going to solve this question very shortly, guys. 45 one. We can read the question and we can end up solving question at the end, right? So this question is from FM. Okay, and this is only the question where you need little time, though this is also very conceptual, I will tell you, right? But we will solve this. Hello. Let us solve this question, question number 50. And these questions for 2 marks. So you should never leave these kind of questions, right? So what they have given here is they have given x1 and x2 be the band limited, two band limited signals. Okay? So band limited means you could just do this kind, you can represent them, right? This is band limited. Okay, x1 is band limited to what? X1 is band limited to this b. You can say this is nothing but minus b and b. Okay, x2 is band limited to the same b, right? Okay, now in each figure, in the figure below, the Nyquist sampling frequency in radian per second you have to find, right? So what you have to find? Nyquist sampling frequency you have to find. What is the Nyquist sampling frequency? That is nothing but 2 times of the maximum frequency of the message signal, right? But what is there here? You are multiplying first. See, x1 is being multiplied with cos pi 4 pi into 10 raised to power 3t. Okay, and then so you can say this is nothing but a b only. Okay, this is nothing but b. This is nothing but what, guys? You can say this is nothing but 3b, right? You have to notice here this is 3b because b is nothing but 4 pi into 10 raised to power 3t, right? So this by you have to find. Once you get y, then you can find out the Nyquist. Okay, so this is the sampling, you can say, I mean this is the band limited signal. Okay, you can represent here this is nothing but x1t. Okay, and second one is x2t, I mean x1 omega you should write. Okay, not x1 omega, and this is nothing but x2 omega. Okay, in omega plane this is omega, right? Minus b to b. Okay, now since you are multiplying with the cos omega naught t, I mean you can say you are multiplying with cos, so it will be shifted, it will go toward plus and minus, right? So you can say that if you are multiplying x1 with cos 4 pi, you can say cos bt, right? So it will be shifted. Okay, so I can directly write, and then you have to add also, right? So let me do like this. And what you have to keep in mind that while finding the Nyquist sampling frequency, you don't have to worry about height of the spectrum, right? You have to only focus on the frequency axis, and that too, that should be omega, radian per second. So if you're going to shift this to the left, okay, so you have to add b, right? So if you add b here, so it becomes 0, and this will be shifted to 2b, right? So 0 to 2b. Okay, forget about this 4 pi and all, 0 to 2b, right? Next, and this will be shifted to like this. This is 1. Okay, now if you're going to shift this, okay, by what, 3b. So 3b means this is nothing but 2b. You can say this is going to be shifting like this. You see, this is b, this is 2b, this is 3b, this is nothing but 3 plus b, that is nothing but 4b. Okay, that is nothing but 4b. Okay, I hope this makes sense. You see here, many of you might realize that, many of you might think that this is nothing but a band pass signal, but it is not a band pass signal, guys. Okay, it is not a band pass signal. Why it is not a band pass signal? See, you have to find the Nyquist frequency, Nyquist sampling frequency for this. Okay, so can you identify that what is the maximum frequency in this case? The maximum frequency in this case is 4b, right? And the minimum frequency, if you notice here, that is nothing but 0. So omega L is 0 and omega H is nothing but 4b, right? So always how to check whether it is not a band pass. Okay, so you have to always go for, you see, WH by WL is must be far greater than 1, right? If you take ratio of this, okay, so it is nothing but a what? It is not a band pass signal. Remember that, okay? Understood. So what you can do here is your Nyquist sampling frequency, Nyquist sampling frequency will be what? Frequency is going to be 2 times of the maximum frequency, that is omega s, 2 times of 4b, that is 8 into b. What is b, guys? B is nothing but 4 pi, okay, into 10 raised to power 3 radian per second. So you can say that 8 into 4, that is nothing but, you just write here, that is nothing but 8 into 4 pi into 10 raised to power 3 radian per second. That is nothing but 32. So this question was very simple question, right? Because it is 0, so it will be always far greater than 1, right? So never consider that this is a pass band pass signal, okay? Remember, okay? I hope this makes sense to you. So this question was again very simple, 2-mark question, and you can easily get 2-mark question for this, okay? So simply what you have to do, you have to understand what is the meaning of band limited signal, right? Having a bandwidth b, and try to minimize the computation. What you can do here is you can replace this 4 pi into 10 raised to power 3 by b, right? So your life become very simple, okay? Otherwise writing 4 pi into 10 raised to power 3 again and again might mess your diagram. So I think this approach you might have liked. Now let us go for question number 59, right? So what they are asking is, xt is a wide Gaussian noise, okay, with the power spectral density they have given 1 by 2 W per hertz, right? Or you can say watt per hertz. If xt is the input to LTI system, the impulse response they have given, right? So you can say that this is nothing but a situation. xt is the input to LTI system, okay, and this is nothing but a by t. By t is what? The output, okay? So they are asking what is the output power, okay? What is the average power of the output, system output, right? And they are given st. St is nothing but e raised to power minus t ut, right? It's a very beautiful impulse response they have given, right? Okay. Now what we can do here is, it's a very simple, right? First of all, what they are asking is, they have given input power spectral density, right? The input power spectral density they have given in f domain, or you can say in f plane, right? So this is given as 1 by 2 W hertz. Okay, so what is output power spectral density? S by, you can say, in f, that is nothing but the h of f whole square times, okay, the impulse response whole square. You have to find the Fourier transform of impulse response whole square times you have to remember this, times the input power spectral density, that is nothing but x of f. Okay, once you have got the power spectral density, so you can find the average power. What is average power, guys? Average power, देखो, what is output PSD? Output PSD is nothing but, always remember this is a formula, that is h of f square input power spectral density, input PSD. But you have to notice here, okay, you have to notice what? You have to find power. So power is nothing but you have to integrate the power spectral density. This is nothing but average power. So integration of minus infinity to infinity, okay, in minus infinity to infinity, the input power, output power spectral, you can say as, okay, df. Now you can plug all these values. So it is nothing but minus infinity to infinity. See, this value is given, okay, this is nothing but half, okay, so we can put here half. You can take half here, and this is nothing but h of f whole square df. Now this is where you have to think little bit, okay? You have to use your signal and system concept. What concept you have to use here is very important, let me tell you. Since you can see here, guys, this is very important point where you have to decide something. Dekho, this is nothing but, see, if you're going to take the Fourier transform, then square it, then integrate it, so that will be 3 to 4 step process. But if you realize that, if you relate this guy with the Parseval relation, what is the Parseval relation? You know, st square dt minus infinity to infinity is equal to minus infinity to infinity hf, okay, hf square df. So you can always use this relation. You can equate the energy, okay? So this is nothing but the energy of what? Energy of the impulse response, right? So you can directly write this as 1 by 2 minus infinity to infinity h of t square dt. This is where you have to understand, right? So 1 by 2, right? What st is given here? St is given as, let me show you st. St is given as e raised to power minus t ut. So your integration will start from where to where? It will start from 0 to infinity e raised to power minus 2t dt. Okay, because your st is a real signal, so modulus does not affect, right? So energy you have to find. So this is nothing but 1 by 2 into, what is the energy of this? If you're going to solve, that is nothing but 1 by 2, right? So you can say 1 by 4, which is nothing but 0.25. This is the answer for this question, right? So the power is but 0.25 watt. How simple this question was, and 2 mark. Okay. Where many students get confused is omega plane and f plane. There is no confusion at all. If you're going to use what? If you're going to use partial relation, right? Otherwise क्या करोगे? You have to find the Fourier transform of st, then you have to take the modulus of that, then you have to integrate, तो वहां पर tan आएगा और confusion create हो जाएगा, ठीक है? तो आपको ये सब avoid करना है. As long as you are able to find the energy from the time domain, so better to find energy of the time domain, right? Okay. There is no difficulty finding energy of e raised to power minus t ut. ठीक है, ये आपको decide करना है हमेशा. If you are able to find the energy of the impulse response in the time domain quickly, so why you are finding energy of the impulse response in frequency domain? ये चीज आप शॉर्ट नोट में नोट कर लो. ओके, समझ आया क्या? So this is very very important to keep in mind. ठीक है, देखो, at this stage you can find the Fourier transform of impulse response, then square of that, integrate, waste your time, right? But what is this, guys? You have to remember this. This is the partial relation, right? This connects the time domain energy and the frequency domain energy. Energy should be same whether you are computing energy in the time domain and the frequency domain. So these things people don't discuss. ठीक है, अगर आप एनर्जी टाइम डोमेन में अच्छे से कंप्यूट कर पाते हो जल्दी से, तो आप टाइम डोमेन का इक्वेशन यूज करो, मतलब जल्दी से आप फाइंड कर सकते हो. इफ यू आर एबल टू फाइंड, जैसे मान लो एक क्वेश्चन, मैं आपको एक एग्जांपल देता हूँ. एग्जांपल क्या है कि मान लो सिंक फंक्शन दिया है, राइट? So you are not able to find energy in the time domain, right? So you can better go for frequency domain, right? Okay, you can find the Fourier transform of sink is nothing but rectangular, then simple, right? Okay, I believe this is fine. So this is the takeaway that you have to take to save your time. Chalo, next question was a very good question, question number 65, right? And this question is from information theory, guys. Information theory. And it is also very easy question. So what they have asked is the frequency of the occurrence of 8 symbols. You can say A to H. Okay, so frequency is nothing but what, guys? Frequency is nothing but the probability, right? Probability. If you have been taught by me, or if you have watched my lectures on YouTube channel, whatever I have taught, for free here, so you should understand, right? So they have given the frequency, okay, of the symbols. So a symbol is chosen and it is determined by the by asking a series of yes/no questions, which are to be assumed to be truthfully answered. Okay, the average number of questions when asked in the most efficient sequence to determine the chosen symbol. Okay, what they are asking is average number of questions when asked in the most efficient sequence, right, to determine the chosen symbol. They are asking average. And average is nothing but, in the information theory you might have studied about entropy, right? Entropy, or entropy यहाँ पर find करना है. That's it. This question needs entropy, right? Because this kind of problem I'm pretty sure nobody discussed, right? But in my class I always discuss this kind of a problem, guys. Okay. So ऐसा नहीं है कि आपको नया question नहीं है. I can show you my notes. I have around 5 to 10 questions, similar questions, right? ठीक है, so ये क्वेश्चन काफी अच्छा आया था. You have to identify what the entropy here you have to calculate, right? So can you compute this quickly? Can you compute quickly the entropy, and you can let me know what is the definition of entropy, guys? The entropy definition is nothing but h of x. You can say h of x is nothing but what? Suppose one symbol is there, right? So one symbol entropy is going to be minus p log p. But there are many symbols, right? So you can say that h of x is going to be, if there are many symbols, right, it is going to be what? P of xi summation p of xi log 1 by p of xi. Why I have put negative here? If you take this 1 by p, like p only, so you can put minus sign. So just, so you find out the entropy here, okay? Corresponding probabilities are given, and you can just add them, so you will get the entropy of that. That is the answer for this question. Okay? So you have to answer this question like this. The average number of questions when asked in most efficient sequence to determine the chosen. So now can we find out? So 1 by 2 times, you know, log 2, you can say, okay, what we can do here is quickly we have to compute, right? So it is nothing but 1 by 2 log 2 means you can say log 2 base 2, that is 1 only, right? So I'm not going to write this entire expression, I will write directly. 1 by 2 into 1 plus 1 by 4 into 2 plus 1 by 8 into 3, because log 8 is 3. 1 by 16 into 4 plus 1 by 32 into 5 plus 1 by 128 into 7, and you can multiply by 2. This is very simple, okay? This is very simple. So what you can do, you can multiply by 2 first. इसको solve करोगे तो what answer you will get? You will get around 1.984 question per symbol. So answer for this question will be what? Rounded off to 2 decimal place. You can say 1.98 approximately. Okay. So I hope this question is done. Okay. So you read the question and how quickly you can find out. You should know what is log 8 base 2, that is 3. ठीक है, तो आपको कैसे अप्लाई करना है फॉर्मूला, दैट मैटर्स आल्सो अ लॉट. बहुत सारे लोग इसी में 5 मिनट ले लेंगे, बट दिस क्वेश्चन डिमांड्स ओनली एंड ओनली 1 minute because you will be using some calculator also. ठीक है, so 1.98 will be the correct answer. So I think this is the last question. Okay, but we will solve one question that was left here, right? Communication system में देखो कैसे क्वेश्चन आते हैं. एक क्वेश्चन मैंने बोला था लास्ट में करेंगे. दिस इज अ क्वेश्चन दैट वी हैव टू डिस्कस, दैट इज नथिंग बट, so in 20 minutes we have done around 5 questions, and the last question we will do. And this question was asked from analog communication. That is nothing but they have given, let a frequency modulated FM they have given, right? And xt is given. So this is nothing but a frequency modulated signal xt, that is a cos omega ct plus kf minus infinity to t. This is the definition they have given, so you don't have to copy the definition again. That is the smart way of solving question. Okay? Don't copy the definition again. Understand that this is the frequency modulated signal, right? Where mt is a massive signal of the bandwidth w. So they have given mt is nothing but a massive signal of a w. It is passed through this mt. This is a massive signal actually. Okay. If it is passed through a non-linear system with a output by t, so what will happen? See, if you're passing through a non-linear system, 2xt plus 5xt whole square. You know that you might have studied in FM, okay, frequency modulation. What you might have studied कि अगर आप नॉन लीनियर से पास करते हो तो क्या होगा, आपका मान लो नैरो बैंड एफएम है तो क्या हो जाएगा, WBFM हो जाता है. ठीक है, WBFM का मतलब क्या है, व्हाट इज वाइड बैंड फ्रीक्वेंसी मॉड्यूलेशन, राइट? तो वहां पर क्या चेंज होगा अगर आप नॉन लीनियर डिवाइस से पास करते हो, तो यू नो दैट फ्रीक्वेंसी डेविएशन विल बी चेंजिंग, you know that your carrier signal will be changing, your beta will change, but your massive signal frequency will not change. Your massive signal frequency will be always W only, right? That is very important to keep in mind. ठीक है, ये आपको पता होना चाहिए. Then only you can solve this kind of question. ठीक है, so this question was very good question. Fine. So what we can do here is, you should know that so what is the bandwidth of the FM signal at first, you should know, right? So what is the bandwidth of the FM signal? Bandwidth of the FM signal, as we know that from the Carson rule, right? What is that? That is nothing but 2 times of delta F plus W. 2 times of delta F plus W, right? That is nothing but a bandwidth. What is delta F here, guys? Delta F is nothing but, or you can say delta omega, right? You can say also delta omega, right? So delta F or delta omega you can say, because after all we are talking about let me take here This is nothing but frequency omega, okay, like frequency deviation plus the massive signal, okay. In other words, you can write the bandwidth is nothing but 2 times of beta plus 1 times fm or omega m. Okay, so you can take inside this, right? So this is what the situation is, right? Okay, this we know, but suppose we are passing the fm signal from the what, from, you can say for this it will be same because 2 times xt it is going to be same. So if you try to draw the spectrum, how we get this formula, right, that you have to also remember. So basically your xt is going to center around omega c, ठीक है. तो आपका जो xt रहेगा that is going to be centering around omega c, that is the carrier frequency, right? Why we are taking carrier as a omega c? Because they are asking the minimum value of omega c required to recover xt from by t, and by t is nothing but a non-linear device, right? By t is nothing but the relationship between by, xt and by t, okay, and they are not, it is a non-linear system because they have given xt whole square, ठीक है. ये फॉर्मूला कैसे आता है, दैट आल्सो यू शुड नो, राइट? हाउ वी गेट कार्सन फॉर्मूला, ओके, फॉर एफएम सिग्नल, बीटा प्लस 2 टाइम्स बीटा प्लस 1 एफएम, राइट? तो हमेशा हम लोग क्या करते हैं, सिग्निफिकेंट जो, सिंस वी नो दैट in case of fm there will be many, okay, many line spectrums, okay, many lines in the spectrum, so we always consider the spectrum which is you can say kind of, near the omega c, okay, near the omega c. That is very important to keep in mind. So your omega c, your spectrum is going to centering around omega c, and we have to go this side delta omega plus w, this side delta omega plus w, 2 times of that, okay. I hope this makes sense. So what you can do here is you can say that moving away from this, okay, this is nothing but omega c, right? Since they have given something here, what they have given, let bt be, bt denote the bandwidth of the fm signal, okay. So what we can say that the bt is nothing but this bt by 2, okay? And if you move like this, right, this is nothing but omega c minus bt by 2, okay. So if you try to see the difference here, right, so the overall bandwidth is bt, okay. This is omega c plus bt by 2, and this is omega c minus bt by 2. You have got omega c center frequency, omega c plus bt by 2, omega c minus, okay, like fc minus fm, you can say fc minus fm, fc plus fm, right? This is how we find out the bandwidth also for fm, ठीक है, क्योंकि उसमें वो इनफाइनाइट बैंडविड्थ होगी. थ्योरेटिकली अगर आप बात करते हो एफएम के बैंडविड्थ की, तो दैट इज नथिंग बट इनफाइनाइट बैंडविड्थ. लेकिन ये क्वेश्चन में दिया है कि द बीटी डिनोट द एफएम सिग्नल बैंडविड्थ. So this is the bandwidth that you have to keep in mind. This is called, you can say that xt ka situation, right? Okay. And now let us pass it through square device. Okay. तो x square t करोगे तो यहाँ पर frequency squaring मतलब frequency multiplier is 2, right? So if you pass it through, xt is being passed through kind of frequency multiplier, so it will become x square t. तो यहाँ पर n की वैल्यू कितनी है, 2 है. What will happen? What are the things that is gonna change? So this will change basically. Suppose यहाँ पर डेल्टा ओमेगा है इसका frequency deviation, so it will become delta 2 times of delta omega, right? Okay, and if suppose this guy has carrier frequency omega c, so this guy will be having carrier frequency omega 2 times of omega c, right? इसका बीटा अगर मान लो बीटा इज द मॉड्यूलेशन इंडेक्स, तो इसका बीटा कितना हो जाएगा, 2 टाइम्स बीटा. बट इसका अगर मान लो ओमेगा एम इज द मैसेज सिग्नल, दीज थिंग्स यू शुड नो, राइट? ओमेगा एम, तो इसका ओमेगा एम ही रहेगा. So these are the changes that you have to understand. Okay, I hope this makes sense. Then क्या करना है, then this is very important. So let me get back, and this question was quite good, right? So then you have got this, right? You don't have to worry about these 5 to all these whatever is multiplied with the xt or x square t, right? Now you can add these two, right? Okay, you can add these two. If you will add here, so what will happen, you can draw the spectrum again. Yes, I will draw it. Okay, so the new bandwidth for x square t will be what? Bandwidth for x square t will be bt plus, you can say, 2 delta f, right? Bt plus 2 delta f, right? So let us draw the spectrum now for, okay, so I'm just going to draw the spectrum for addition of that xt plus x square t. So it will be centering around omega, like xt will be centering around omega c, and x square t is gonna be centering around 2 omega c. ये आपको पता होना चाहिए. That is very important to keep in mind. Okay. Now, and this will be nothing but, this is, you can say, this is nothing but omega c plus bt by 2. So this is nothing but xt. Okay, and we are talking about x square t. X square t will be what? 2 omega c plus, you can go this side, you can go this side, right? Okay, that is very, very important. So but here now there will be what? There will be delta f also, right? So that is very important. So this is going to be 2 omega c plus bt by 2 plus, you can say, delta f, right? Plus delta f. And this side क्या हो जाएगा यहाँ पर इसका 2 omega c minus bt by 2 minus delta f. Okay, minus delta f. Understand? Yes. This is the spectrum that you have to look for. Now, what is the question? According to the question, we have to go now. What question they have asked here is, question they have asked the minimum value of omega c required to recover xt from by t. So from by t you have to recover xt, right? तो क्या करना पड़ेगा? by t से xt recover करना है. So what is the minimum value of omega c? ठीक है, that is very important to keep in mind. So you can see here, you can compare now two frequencies that you have to compare, right? That is very important. Okay, so this frequency you can compare, right? Okay, and this frequency you can compare. Which frequency? Okay, these two frequencies you can compare. They should not overlap. Okay, so this point should be greater than this. Then only you can recover it. Okay, this non-linearity should not affect your xt. That is very important. What you can do here is to recover, let me take some new page. आपको याद रखना है ये पॉइंट हमेशा क्या होना चाहिए, दिस शुड बी ग्रेटर देन दिस टू रिकवर इट बाय some means, you can say, right? So let me add new page. So you can say that this point, okay, this point is nothing but 2 omega c minus, okay, let me write don't write delta f here, guys. This should be delta omega, right? Everything should be in omega. Okay, everything should be in omega, right? Okay, so what we can do here is now 2 omega c 2 omega c minus bt by 2. Consider this bt in the omega plane only, minus delta omega should be greater than, right? Should be greater than what? This omega c plus bt by 2. Right? Now you can take this omega c this side, so omega c this side you have taken, and you can take this bt that side. Okay, bt by 2. Okay. So these are the things that you have to remember always, right? So omega c will be greater than what? Omega c will be greater than delta omega plus bt. Understood? This is very important to keep in mind. Okay. Okay. Now what is this bt? This bt is what? This bt you have to keep in mind. What is this bt? So this bt is nothing but, okay, this bt, once you pass it through once you pass it through this square of that, okay, like squaring devices or nonlinear devices, so this bt will change. This bt is nothing but, you can write 2 times of delta f, okay, 2 times of delta omega, you can say, right? That is very, very important to keep in mind, right? So आपको ये याद रखना है. So this is nothing but omega c delta w plus This is after passing, okay? So you can say this is nothing but 2 times of, okay, delta omega plus 2w, okay, 2w. That is nothing but a, okay, frequency, massive signal frequency, right? Okay. Now, so omega c is going to be, this is what, guys, you can say this is nothing but 3 delta w, delta omega plus 2w. Okay. I think this is clear. Okay. Now what you can do here is you can plug what? You can take something out, okay, and you can just, you have to adjust it, okay, because you have to get BT. Your answer should be in terms of BT, right? So BT is given as what? Your answer should be in terms of BT. So BT is nothing but, your BT is given as 2 times of delta omega plus omega w, right? Yeah, ये थोड़ा सा lengthy question है. So this kind of question you can also forget. I mean, you don't solve it, but it's okay. इसको आपको adjust करना पड़ेगा. So what you can do, omega c, इसमें आप 2, you can say 3/2, you can take common also, right? So 3/2 if you take common, ठीक है? These are the adjustments that you have to do, right? 3/2 you can take common, and 2 times of delta omega minus, you can say, plus w minus w, right? Okay. So if you take 3/2 inside, so it is nothing but 3 times of bt, और वही आ जाएगा, right? So इसको आप बोल सकते हो this is bt. So omega c should be greater than 3/2 bt, capital BT minus w. Now this is a massive signal frequency, so you can ignore it. Ignore. So your omega c, minimum omega c will be equal to 3/2 bt. So you, in order to get this answer, you have to do this much effort, right? So 3/2 bt will be the correct answer for this question. These are the wrong. Okay. So I think this is clear, guys. We will meet in the next session. Okay. So this was all about communication system. Only this question was little lengthy, so you can also forget about this question if you are not able to solve. But other question you can do it. Okay. So we'll meet in the next session and we'll come up with new subject. Thank you.